Assalamualaikum and hi. Good day to Dr. Khairul Anwar and my fellow friends. In this video, we will present about our progress in designing a beach cleaning machine. Before I proceed, I would like to introduce myself and my team members. My name is Muhammad Zulimi bin Muhammad Fida, and my team members are Muhammad Imramullah bin Hafizal, Muhammad Aiman bin Jafar, and Muhammad Faris Alani bin Khairul Anwar. We are all from Group 2. The content of this presentation are introduction, design requirement, project management, background research, concept generation, conceptual design, and concept selection. As for the introduction, I will explain about project summary, objective, and scope. For project summary, beach littering is one of the main problems faced in our country, and it has become a major global concern. Beach littering can cause many problems, such as destruction of a tourist attraction, the endangerment of an ocean species, and could even pollute neighboring countries. One of the main problems of cleaning beaches is human labor. Humans can't keep cleaning beaches 24/7. There is a limit of an area one person can clean up. In addition, acquiring many workers to clean up beaches is expensive and hard to manage. To combat this issue, an automatic beach cleaner can be built in order to help humans with solving the littering issue on the beach. This machine can help to reduce human resources and the costs associated with cleaning up the beach. The objective of this project are to clearly identify and describe the problems and scopes of the beach cleaning machine project, to collect, analyze, and present data in meaningful information using beach cleaning machine project-related tools, to select, plan, and carry out an appropriate problem-solving methodology. The team have to solve the problem and build the beach cleaning machine in an efficient and ethical manner, and also effectively present the results in written and oral form, as well as complete virtual prototyping. The scope of this project are the beach cleaning machine only works at sand beaches on the surf zone only, usually between 5 to 10 meter in depth. The size of the litter cannot exceed the size of machine's collector. The machines can only collect floating litter on the ocean surface. The system should be able to collect the litter autonomously. The system also should be able to move on the water surface, withstand sand, small waves, and seawater. The machine should be able to work in a certain range only. The model should not have complicated shapes, so it is easier for the fabrication process. The collection system should be based on a suction system. The machine design should be easy to maintain, and the system should be able to operate 24/7. And last, the machine should be environmentally friendly. Pictures show the area of the operating machine on the surf zone only, which is within 5 to 10 meter in depth.
Okay, I will continue presenting for chapter 2 or part 2 of for the slide for design requirement. I will explain more detail about the product design specification. For our design, we focus on the performance for fully automated as required for the project. Second is able to collect the trash on the surface of the ocean, able to collect and sub in both trash and oil to the container, which is the storage chamber, able to withstand the watery condition and hot weather as we design for the ocean, able to operate at least 50 seconds without requiring maintenance, easy to operate with many procedure, can be easily maintained, can be operated up to 10 meter in radius. This is for the specific distance due to we are working on the large area, which is the ocean. Materials used are resistant corrosion, lightweight and strong. lifespan of 4 years. The sponge, the storage and sponge must be cleaned once per 3 days, because the storage is specific for the trash and the sponge is specific for the oil on the ocean, able to collect and suck in both trash and oil. For the location, we decide to do at the sand beach, which is the zone as stated before, because of the wave is not too strong there, and the product cannot, the device is not easily be drifted by the wave. And okay, for the size, the total dimension storage each population should not be exceed 1 by 1 meter, which is considered too large for a floating device. Weight is not less, is 30 kilogram, including the water pump. This is because if it too heavy, it will consume much more energy. Material resistant to corrosion and damage, resistant to environment factors such as the wave itself, lightweight, and insulated material. Okay, the next one is the cost. The maximum budget for this product is 500. The demand on the machine would be high due to its flexibility and functionality. Environment, not harm the ocean ecosystem, and no aquatic life will be trapped in the storage. As we design we are focusing on the ocean surface only, able to withstand the wave on the ocean floor. The noise level must be below than 90 decibel for 8 hours a day. Quantity, 1 unit as proof of the concept. Maintenance, easy to service, maintain due to the availability of spare parts in Malaysia, replacing the lubricant used for the motor, producing lifespan 10 to 20 years. Suction mechanism, which is the pump or the motor, the lift the ocean water and overcome frictional force of the pipe. The second one is overcome the pressure difference between the pump and the outlet of the system with zero flow to lift up the ocean water. As we design this to collect all the trash by using the water flow. So we need to use the suction to bring the trash into the storage chamber. We are using centrifugal pump. Design is preferred as it can efficiently suck in ocean water. This is because centrifugal pump is much more efficient compared to others pump for water suction. The device power source is the first one is power consumption, which is 1 horsepower or equivalent to 750 watts. Power supply is about 180 volt to 220 volt and 50 hertz. Filtration collection, cellulose filter media as it provides less restrictive to oil flow and capable of absorbing water from oil. The second one is large surface area to fill as much oil as possible. The mesh filter should have a 2 to 3 millimeter gap. This is for the absorbent part. The movement and motion able to move at least from one point to another to collect the trash on the beach. For the transferring, the piping must be long service life, low maintenance cost, reasonable fees, and 100% recyclable, which made from plastic or any polymer. The second one is surface must be clean and free from grease. This is the main purpose because we need to suck the oil, and if there is a grease, we just increasing the oil on the surface of the ocean. Eliminate a bubble to avoid pressure loss. This is one of the most important feature because we need the pressure to make it function efficiently. Storage, the size of the storage at least 10 liter of water, 10 liter of 10 liter of water. The material are waterproof, lightweight, and high tensile strength. The design of the storage is easy to clean. Next is standards. Okay, this is the standard for the manufacturing that we follow. First one is ISO 9001, ISO 6385, 1001, 101 for environmental responsibility management, occupational health and safety for this is for labor, welding, mechanical power transmission, to determine the proper pressure. This is the standard that we use. For the pattern, there's several pattern there that we are referring to. The first one is beach cleaning machine, floating skimmer, apparatus, and method of removing floating debris, beach cleaning apparatus. Service life, the device or the machine at least lasts for 4 years. All critical part of the motor, filtration system, and pumping system should be serviced. The tool will be shipped according to request to of the customer, and the cost of the delivery is based on the location of the customer. This is for the service life. And the lastly is the point of this project is the main point for this project is autonomous, able to operate with high degree of autonomy, need to be monitored from time to time to clear the storage, only for to clear the storage, and the operation is fully autonomous. The tools should help to collect trash. Tools should be able to store easily and operated. For the safety, tool must be safe to be used. Sharp edges only present on the movement mechanism. Uh, Pinch point use must be minimized, and those present must have question warning. Those present must have question warning. The moving part of the movement mechanism must be enclosed. There should be warning near to the collector mechanism. Inclusion of the user manual is a must. People monitoring and machine from time to time. For aesthetic, show a sense of reliability and safe to use. Preferably something bright in color so that it doesn't not absorb the heat from sun, and if it's too dark it's maybe hard to detect it on the ocean when the device is drifted. A bright color should to also allow tool to be more quickly noticed. This is for the third point. Manufacture process require the use of heavy machinery designed for solid work and 3D printed for the model. And test on the watery environment. The suction power of the machine should be high enough. Shelf life storage. Shelf life is 10 to 15 years. For the time scale is 11 weeks for the final design. Final prototyping and other documentation, not including fabrication. Okay, that's all from me. Thank you.
As for the project management, we have provide work breakdown structure. For introduction, we have done on problem identification, internet findings, objective and scope, market research, WBS, Gantt chart, and technical paper writing. While for background research, the works include are to study and develop the characteristic of machine, type of litter, machine limitation, problem phase, product design specification, project proposal, and mind mapping. Next, for concept generation, we have to provide functional analysis, morphological charts, and conceptual design. For conceptual design, each of us has to generate three concepts that then to be evaluated and select the final concept. Next, for concept development and engineering analysis, we have to produce initial design a CAD model, parts and function, build of the material and material selection, failure mode and effect analysis, fault tree analysis, and design improvement. Then, proceed to virtual prototyping and modeling and working on simulation of the design. Lastly, we will provide a report writing and presentation of our project. For Gantt charts, each team member will be a leader for 3 to 5 weeks and has a responsibility to ensure the workflow is done efficiently. For the first 3 weeks, Iman will be the leader and the work during the weeks are background study, problem statement, research and design specification, and concept generation. For the following weeks, Aiman Jaafar will be the leader for this group and has to make sure the outcome of the tasks, which are morphology charts and concept specification, are achieved. The task for the next 3 weeks will be responsible under Alani, which we have to develop concept evaluation, concept selection, initial design embodiment, and bill of material as well as material selection. From the week of 10 to 12, I have to ensure the task which includes design efficiency and computer modeling, engineering analysis, and virtual prototyping to be done during the period of time. For the last 2 weeks, we plan to finish the prototyping and provide a report as well as presentation of the overall project.
Hi, Assalamualaikum. My name is Muhammad Imarwa bin Hafizan and I will present about the background research as well as the concept generation. To start off, this is our mind map. So, firstly, we will look at the issues. So, the first issues is the environmental issues, strictly about the sea life. So, the sea life, when we pollute the ocean or the beach, the sea life will eat the trash and continue to starve or suffocate. And it will also affect the aquatic life. This is all cause of presence of microplastic and trash in the ocean. And the second issue is also the productivity of man. So when there are many trash in the ocean, there will be high manpower cost. Since man is not equipped to clean the ocean, there are limited working hours for them. So productivity will be slower. And manpower can't do the work during harsh weather. This is true since the harsh weather is hazardous for them. And the health issues is when there are trash in the ocean or in the beach, the water will be polluted and it will cause diseases. So, what is the type of trash that we want to clean? For example, we will clean the fishing net, straw and stirrer, plastic such as plastic bottle, plastic bags and so on, glass bottles, or leakage, food container, buoy and cigarette butts. This is the type of trash that we want to clean. So, what is our target user for our beach cleaning machine? Is for the sea officer, cleaning company, tourism activities, beach resort, hotel and also ranger. So, how do we want to clean the ocean? The way we want to clean the ocean is by passive water treatment or sifting or automatic machine, which is our primary focus here. And also raking, so raking on the water or on the sand using a vacuum on the ocean or using a wireless robot. So, lastly, we come up with 6 design solutions for the beach cleaning machine. Firstly is the vacuum beach cleaner. For the vacuum beach cleaner, we can only suck the floating microplastics and it will be lightweight and easy to use. For the pump, and absorb and pull the oil leakage, since the pump will be powerful enough to absorb both the trash and the leakage and trap the floating trash. So for the raking, we will equip them with a rotating conveyor belt and can quickly sweep up the trash on the beach. And for sifting, we can collect the waste while returning the sand back to the beach so that we will not cause any disruption on the surface of the beach. And we will equip it with a vibrating screening mechanism. Combined raking and sifting is the same thing, but combine the both of these mechanism. So it will result in a faster filtration. So lastly, design solution is the robotic arms. So this robotic arm can be controlled by an expert worker and can differentiate between trash and sand using a sensor. So next, I will talk about the concept generation of our beach cleaning machine. There is an input, a general segment, and an output. The objective is to suck in the trash and ocean water into the bin. We need a water pump generated by electric power, and we will separate the trash and oil to get a clean ocean water and release it back to the ocean. So this is the more detailed explanation. So there are 4 inputs here and 5 outputs. The energy will import the electricity, and the actuated electricity will convert the electricity into the rotational energy. This will dissipate sound, and thermal energy will result in noise and also heat. Also, when we pump in the water, they will input the ocean water, and convert the rotational energy into hydraulics from the electricity, and this will import the soil and oil from the other two inputs, which is trash and oil. So this is export the liquid and will export the clean ocean water out of the system, and we also store the both the solid and oil. Solid mean the trash, and then we will collect the trash and oil when comes to maintenance. Next, I will explain the function of the system. There are 9 total functions of the system, which is oil filtration, trash filtration, movement and motion, floating mechanism, pump and motor, power source, suction compartment, transferring and position fixing and sinking mechanism. Firstly, I will explain the oil filtration. There are two sub-functions of the oil filtration. Firstly is the oil storage, where we will store the oil in the storage. So the direct absorbing in the second sub-function, oil will be absorbed from the water surface, where the oil will be exposed directly to the ocean water. Next is the trash filtration. So there are also two sub-functions of the trash filtration. First is the collector, which will collect all the trash from the water surface mechanically and then transfer to the storage. In the storage, the collection of trash is in a storage where the storage is detachable. For the movement and motion, firstly there are position fixing that is required so that the system will be hold in place and avoid drifting in the ocean in case of power outage. Then the next sub-function is making the machine move. So the machine will be moved remotely to get more trash and oil from the water. Next is the floating mechanism. This is the buoyancy mechanism where it will ensure the mechanism can stay afloat above the water surface to collect the floating trash and oil. It will also provide a high stability on the ocean to reduce capsizing. Next is a pump and motor. This is used to create pressure difference inside the system to provide water suction to suck in the trash and the oil into the system. Next is the power source. The main source that we will use to power the system, and the suction compartment, which is the entrance of the water flow from suction and will act as the collection compartment. For the transferring, it is used to connect between suction compartment to the water pump and to flow the water into the system. And lastly is the position fixing and sinking mechanism, which will prevent the mechanism from drifting due to the wave or the wind. Next is the morphological chart for the system. So firstly is the oil filtration. The first one we got a two-way filter. Next is a three-way filter where they got two inputs and one output. Next is the spinning filter which will spin around. Next is a sponge where it will absorb the oil, and also oil absorbent filter mat. So fine mesh screen filter, centrifugal filter, oil absorbent cylinder, and also the last option is no oil filtration at all. And the second mechanism is the stretch filtration. First is the rounded bucket and a net, and a square bucket, a cylinder bucket, a net with ring, an open box container, or we just don't include the trash filtration at all. A sub-function of the trash filtration is the trash collector, which is the roller, a raking, sifting, or lastly we just don't include it. The third mechanism is the movement and motion. Firstly, there is a cable line with motor where the cable line will be fixed in two directions. System will be dragged from each end to the other end. Next is the zip line with motor on the machine, which act as the same as the cable line, but the mechanism for the rotating of the movement will be built onto the machine instead on the cable line. Next is the propeller. Next is the thrust fan, a water pump exhaust so that from the exhaust from the water will move the machine. A water wheel where the water wheel will spin around and create a force to move the machine. And lastly, we just don't include the option. Next is a floating mechanism with a floating stick, buoyancy concept, a raft, a buoy, semi-sphere boat, catamaran boat, two wings, and not include a floating mechanism at all. Next is a pump and motor. We use gasoline water pump or centrifugal water pump, or we just don't include the pump and motor. For the power source, we use petrol, solar, battery, wind, wave. Lastly, we don't include it. For the suction compartment, we use a round bucket, a rectangle bucket, a water channel, pipe with hole, split channel, and not included. Next is transferring. We use a ring pipe, a built-in compartment, polymer pipe, hose pipe, flexible pipe, and not included. Lastly is the fixing and sinking mechanism. Firstly, we use anchor, a fixed pole, a buoy, a set, or lastly, we don't include it. That's all for me. Thank you.
Okay. Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh and good day. My name is Muhammad Aiman bin Jaafar with the number metric of A18 KM0189 So today I will present about the conceptual design and conceptual selection from my group 2 for this system design project. So every team member need to provide 3 conceptual design, and for my group we have 4 team members, so total of 12 conceptual design we will provided, and each conceptual design need to follow the product design specification PDS that have been provided. So let's get started. Okay, so let's start with the first conceptual design. Okay, this design is basically a stationary design in a rectangular shape, which the water will flow into this mesh filter when the pump is on, and the water will filtrate by the oil sponge container, and after it have been filtered, the clean ocean water will flow out back into the sea. So next, conceptual design 2. Okay, as you can see, this conceptual design is a moving device guided by a rope slide, which a boat-like design. As you can see here, we will put 2 field checkpoint, which the device will move from one place to another. And same as before, we will use water pump to suck in the ocean water with the trash. And as you can see, underneath the mesh filter, we put some oil absorbing sponge, which will filtrate any oil or waste that floating on the water, and the water will exhaust back at the rear of the device here. Okay, so next, conceptual design 3. Okay, this conceptual design also a moving device which guided by a pair of propeller here and next here, which will rotate clockwise, and this device will move forward. So the trash and oil will enter this compartment passively and trap into the box filter, and on the box filter we will put oil absorber mat to trap in the oil on the ocean water. So next is conceptual design 4 prepared by Aiman. As you can see here, this concept is based on the DIY concept, which the machine is supported by 2 buoyancy tank to make sure it will float on the surface of the water. So the mechanism of this machine is same with other. When the pump is on, the ocean water will suck into the collection storage and the cache bag, so the trash will trap into the cache bag, and the water will flow into the filtration system and will be filtered and then goes back into the ocean. And this machine is operate using electrical energy, which will power up the propeller to move around and the pump system, and also will be supported by the solar power cell to support the electrical energy. That's all. Okay, for conceptual design 5, we are going to use the water wheel concept, which if you can see here, it rotates in 2 different directions and create a water flow to guide the trash into the storage container. And if you can see here, the body shape is using a hovercraft mechanism, and the mobility is using the thrust fan to move forward. So next up, for the conceptual design 6, here as you can see, we are going to use 2 RC boat, which using the electric battery for the power generator, and the net will move around guided by this navigation system to collect the trash. And this system also can be semi-autonomous, that can be controlled by the remote control. So next, we will look into the conceptual design 7 prepared by Alani. So all the equipment like the storage, the pump and the filter are inside one main body shaped like a sink. So the mechanism same as before. So when the pump is power on, the ocean water will move into the mesh and trap by the filter, and the water will flow into the filtration system and exhaust back into the ocean. And as you can see here, there are a chain below here. This device will stay in one position, held by the anchor, and it just will move around the range of the length of the anchor. So next, for conceptual design 8. So this device is based on a moving raft. If you can see here, the shape is flat and the trash collector is in rectangular bucket shape to maximize the trash collection. So the mobility of this device is by using cable. If you can see here, there are two-sided cable. So same like Iman before, there are 2 points. So the machine will move on the track. So next, for conceptual design 9. So this same as before, the mobility is based on chain and cable, so it will move along the track also, and the bucket suction is kind of can be expandable or moving. If you can see here, it is shaped like a straw, so it can be expand and contract depend on the how it want to collect the trash. So next, we are going to see the individual concept design prepared by Zulhelmi, the conceptual design 10. As you can see here, the design is using catamaran boat system design. Here, these two. Catamaran boat basically have a multi-hull or two hull to prepare high stability to move on the ocean surface. And it also have the oil absorbent tube to direct absorbing any oil that have on the surface of the ocean water, and the trash will be transferred and collected by using the conveyor belt here, and it will collect and move into the storage compartment. And also the machine will run by using solar or battery power. Next, we will see on the conceptual design 11. Here, same as before, it also will use the conveyor belt, the racking system, to transfer and trap the trash into um, the net, and it will use two hemisphere shaped board for the floating mechanism, use the propeller to move around, and the oil absorbent filter made for the direct oil absorbing here. And also here it show the solar panel to support the battery used for moving the mechanism, the machine. So next, for the conceptual design 12, as you can see, the design is flat and it based on, so for concept so next we will look onto the conceptual design 12. Here it is based on a flat based floating system, so the surface of this mechanism is flat to provide better stability. And how it is work, when the machine move forward, this rotary collector will rotate clockwise and start collecting any trash of or oil on the surface of the sea. Here, if you can see here, it contain fine mesh and screen filter which will trap any oil or trash and move into the built-in compartment to collect the trash. And if you can see here, all of these are powered by fuel. So next we are going to see for the concept selection. So as I shown you before, the 12 concept. So next we are preparing the concept screening metric, which we are the evaluation for this for the concept is to compare with the datum of the project. So for the marking scheme, if the concept is better than the datum, +1 will be given to the concept. And if the performance of the concept and the datum is same or equal, so 0 mark will be given. And if the concept is lag or have a disadvantage compared to the datum, -1 will be given to the concept. So there are 3 stages that we have been done. So first stage is the first screening matrix, which from the 12 concept we will only choose 6 concept and make a design improvement. Then the next stage we are going to do the second screening process, which we are going to choose 3 concept from the 6 concept that have been filtered out from the first screening process. And after that we will proceed to the scoring. So for the scoring, we will improvise the concept screening metric by create a suitable weightage. So this weightage will be more specific in the mark, and each criteria for the weightage will hold 5 points. So these are the selection criteria. So as you can read below, the selection criteria is based on how it can be operated, portability, the maintenance, the oil filtration, how the storage oil capacity, the manufacturability, trash filtration, user-friendly, large trash storage capacity, appearance, mobility and movement, overall system, range operated machine, endurance machine, stability on the sea, environmentally, position fixing and sinking mechanism, autonomous in trash and collection, trash oil collection efficiency and manufacture cost. Actually, the selection criteria is also based on the PDS, and we also make some improvement to choose which of the best from the concept. So this is the datum for our project. This is the C bin created by the C bin group. So this C bin is estimately can collect 3.9 kg per day of trash, and the power need to operate this is only 110 watt or 220 watt outlet. So next, so this is the result of our first screening process. So we are compared to the CBIN, our datum. So as you can see here, the design C2, C3, C4, C6, C7 and C10 are chosen from the first screening process. So after the first screening process, as I said, we need to make some design improvement to check, to improve what we are lacking from the previous conceptual design. So this is C2, C3 after the design improvement, C4, C6 after the adding some design improvement, C7 and C10. Okay, so here are the result for the second screening process. And same as before, we only use -1, 0 and +1 for scoring for the evaluation for the second screening process. And the result are all C2 are been chosen, C7 and C10. So the criteria is still same as before. And so lastly is the scoring process and the final concept selection. So from the second screening process, C2, C7 and C10 are chosen for the scoring process. And the evaluation for the scoring process is a bit different compared to before. We are going to use weightage with 5% for every criteria, and the marking is 0 to 1. So every scoring evaluation will be times with the weightage to get a total mark for every criteria. And the result are for C2, the mark is 53, for C7 62, and this for C10 is 53. So the final concept selection will be the C7 with the total mark of 62. But after make some analyze based on the conceptual design, we gather the information that there are 4 criteria need to make improvement for the C7, such as trash filtration, large trash storage capacity, mobility and movement, and trash and oil collection efficiency. These 4 criteria, the concept doesn't get the highest mark, so there are some improvement can be made before proceed to the next process. So that's all from me. Thank you.